Hello, good evening, ma'am. My name is Rishav. I'm from Section D. My provisional number is 208. I'm going to present on a topic nuclear physics. As nuclear physics, we can see that the topic comes from the word nuclei. And nuclear physics is the field of physics that studies the building blocks and interactions of atomic nuclei. It has some many interesting facts. Nuclear power plants produce 790 billion kilowatt hours of electricity in 2020. It is more than 52% of America's clean energy. And nuclear energy is considered the most reliable energy source in America and many states like China, America, and Canada. Nuclear fuel is also a very extremely dense fuel. Now we'll talk on the topic nucleus. Every atom contains a center, an extremely dense positively charged nucleus. As a nucleus, it is made up of two things, protons and neutrons. Protons are of course positive and neutrons have no charge. It's neutral. Now I move on the topic alpha ray scattering experiment by Ernest Rutherford. It is a very famous experiment which concluded that existence of positively charged core of atom, then called nucleus. What Rutherford did is that he bombarded alpha particles on a thin sheet of gold foil. And what he observed? A major fraction of alpha particles bombarded towards the gold sheet passed through it without any deflection, and most of the space of an atom is empty. And some of the alpha particles were deflected by the gold sheet by very small gaps. Hence, the positively charge of an atom is not uniformly distributed. And what he observed next is very few of alpha particles were deflected back. That is, only a few alpha particles has nearly 180-degree angle of deflection. So, the volume occupied by the positively charged particles of an atom is very small as compared to a total volume of atom. Now we will see what is the nuclear force. Some characteristic of the nuclear force are it does not depend on charge. It is a very short range. The range is very small. And why I told it does not depend on charge? Because the force between two neutrons and a proton and a neutron are nearly the same when electromagnetic forces are ignored. That's why it does not depend on charge, it's independent on charge. And it is very much stronger than the electric force. And also we have learned in the basic classes the mostly strong forces types of forces are strong nuclear force and weak nuclear force. It is saturated force and it favors formation of pairs of nucleons with opposite spin. Now we'll move on to radioactivity. The spontaneous emission of radiation by unstable nuclei to become stable, or the emission of ionization radiation, or a particles caused with the spontaneous disintegration of atoms, atomic nuclei, etc. It do attain stability by the emission of alpha particles, beta particles, and gamma rays. Alpha particles are the atomic number decreased by 2 and mass number decreased by 4. And in case of beta particles, electrons and positrons, atomic number changed by 1 and mass number remains same. And gamma rays are of course energetic protons. Now we'll see what is half-lifetime. What does it mean by half-lifetime? It means the time required for the disintegration or to finish the half of the sample of anything. Like how much time you want to finish a half of a chapati or half of a paratha. Paratha will be finished very fast. Like that, it is. It's different for different elements. As I told, chapati will finish in late and paratha we can finish earlier and very fast. It's applied for the estimation of age of fossils. It's spotting seed dating, it is called. And it's used in some dinosaurs, all the old dinosaurs. Here you can see a chart or table which says about the half-lifetime of the all the elements. We can see that uranium half-lifetime is very high. It's 4.5 and 10 to the power 9 years. It's so much time to disintegrate only half. And we can see the protactinium is 1.14 minutes, only half. So it depends on elements to elements. Now our next topic is nuclear reactions. A nuclear reaction is a rearrangement of nuclear components induced by particle bombardment. There are two types of nuclear reactions, fission and fusion. Nuclear reactions are subjected to the following conservation laws. First law is of charge. Second is momentum and angular momentum. Third is energy and total number of nucleons. Now we will see what is fission. Fission means splitting, alag hona. Splitting of large nucleus to smaller ones results in the liberation of energy. In this reaction, more than 20 megavolt energy is liberated. Emitted nucleons can induce additional fusion chain reaction. And chain reaction is controlled and applied in fission reactors. And when it's become uncontrolled, it's applied in atom bomb to create mass destruction. Now we'll see how a nuclear fission reactor works. A place where controlled fission chain reaction works. As I have told in the previous slide, when it's controlled, it's used in the reactors, and when it's uncontrolled, it is used in our atomic bombs. And here, liberated energy is used for the production of electricity. Parts of reactor, there are many parts of reactor. First is fuel, in which uranium, plutonium is the basic fuel which is used in reactors. And then moderator. What moderator? Mostly we use hard water in all the moderators. Graphite slow down neutrons. And control rods. Control rods are absorb neutrons, so cadmium like cadmium. And also we use concrete wall block radiations. Now we'll move on to our next topic, which is fusion. Fusion means to join, to to make two things to one. Here, two light nuclei fuse together to form a heavier nucleus results in the liberation of energy. Is reaction to show fusion. It is the primary source of sun's energy. Sun's energy comes from fusion. Also, it's applied to create mass destruction in hydrogen bombs. Now I'll tell about the differences of fission and fusion. Fission means splitting of large mass nucleus into two medium mass nucleus. And fusion means joining of two mass nuclei into a larger mass nuclei. When the energy released in fission it is less and in fusion it is large. Fission is always uncontrolled, but fusion is controlled. And heat is not needed in fission, but heat is needed in fusion. That's why the energy is not controlled in fusion. That's why hydrogen bombs. But in fission, we used to make atom bombs. Now we'll see what the nuclear reactor uses as its fuel. Fission reactor uses fission of heavy elements like uranium, plutonium for its power. Now we'll show the applications of the nuclear physics. It's mostly used in medical radioisotopes for imaging and therapy. And also in hospitals, we have seen that our doctors used to tell us to do MRI, magnetic resonance imaging. Here also nuclear physics is used. Also, it is used in identification of materials. Identification materials means also it is called positive material identification. It is used to analyze and identify materials for quality assurance or quality control to verify proper alloy or what is the material used in it. It's applied also in dating of materials and power generation, as I told in nuclear reactors. Most of the countries are using.